You're welcome back. In this lesson, we are going to be solving this system of equation. X plus square root of y equals to 5 and square root of x plus y equals to 2. Let us begin by labeling this equation 1, and we'll label this, let's call this 2. Next, we can either add the two equations or we can subtract them. Well, I'll choose to subtract this such that we have x plus the square root of y and minus the square root of x plus y is equal to 5 minus 2. And when we open this, we have x plus the square root of y and minus square root of x minus y is equal to 3. Okay, if I rearrange this, I have x minus y and minus square root of x plus square root of y is equal to 3. Better still, this is the same thing as x minus y and minus square root of x minus square root of y is equal to 3. Well, this and this is very much alike, and you're going to see the reason why I am doing this. Well, you recall that if you're having something like, let's say, m raised to the power 2 subtracted from, then you subtract n raised to the power 2 from it. It's going to be the same as m plus n multiplied by m minus n. So I hope you recall this property. Well, let's apply that here, such that since we are having square root here, we can make this look like this. So this will be the same as the square root of x plus the square root of y and multiplied by the square root of x minus the square root of y. When you open this bracket, you will get this, and minus the square root of s minus square root of y is equal to 3. So at this point, square root of x minus square root of y is common. So I will factor that. So we have the square root of x minus square root of y. I'm factoring that out. So and I will be left with the square root of x plus square root of y and minus the coefficient we have here, which is 1, and it's equal to 3. So at this point, since we have 3 on this side, and we have a product of two factors, if these factors are integer, as long as these factors are integer, the only set of possible solution is if this two factor here is a product of 3 multiplied by 1 or 1 multiplied by 3. So that is what the square root of x minus square root of y and the square root of x plus square root of y minus 1 will be. So we can conclude at this point that the square root of x minus square root of y is equal to 3, and the square root of x plus the square root of y minus 1 is equal to 1. Or better still, so we'll take this as the first set of equation. It can also be that the square root of x minus square root of y is equal to 1, and the square root of x plus square root of y minus 1 is equal to 3. Well, from here, it's much easier now to find x and y. But it will be difficult for us to be squaring both sides or something like that. So let the square root of x, let it be something like a, okay? And let the square root of y equals to b. And by so doing, the first set here becomes a minus b is equal to 3. So, and this will be a plus b minus 1 is equal to 1. So let us solve this set of equation from here. So we have, let's solve it by substitution. We have a in the first equation here. Let us call this 3 and call this one 4. A is equal to 3 plus b. I'm putting this here. So I have 3 plus b and plus b minus 1 is equal to 1. This is 2 and this is 2b. So I'm bringing the 2 here. That's equal to 1 minus 2. Next, I need to divide both sides of this by 2, and b is equal to negative 1 divided by 2. Well, let's go on and put that. Let's put that in the first equation. So we have a minus b is equal to 3. So that would be a minus 1 divided by 2 is equal to 3. And we have a is equal to 3. This becomes positive. We bring it on this side. Minus 1 divided by 2. And the LCM here is 2. So this is 5 divided by 2. A is 5 divided by 2. Well, I'm not okay with this negative result. Well, let's proceed. Let's go on with the other set of solutions. So we have when a is equal to, for the first set of equation, when a is equal to 5 divided by 2, b is equal to negative 1 divided by 2. Next, let's proceed to the next one. The next set of equation is a minus b is equal to 1. So let us call this one 5. And a minus b, a plus b minus 1 is equal to 3. And I'll call this 6. Okay. So from the equation 5 here, a is equal to 1 plus b. I'm putting this inside here. So we have a. So we have 1 plus b minus 1 is equal to 3. And this is gone. And we have 2b here. So 2b is equal to 3. And b is equal to 2 divided by 3. Let us put this in the first equation, which is a minus b is equal to 1. Here we have b is 2 over 3. So a minus 2 divided by 3 is equal to 1. And a is equal to 1 plus 2 divided by 3. This will be 3, 5. And a is 5 divided by 3. When b is 2 divided by 3. Well, these are the set of solution for x and y. Now, how do we obtain that now? Remember, we set our square root of s is equal to a, such that the solution for a is going to be, in the first case, we obtain a is equal to 5 divided by 2. So if a is equal to 5 divided by 2, square root of s will be equal to 5 divided by 2. So we square both sides, and that s is going to be 25 divided by 4. And if the square root of s is equal to, for the second answer for a, which is 5 divided by 3, we square both sides again, and we obtain s is equal to 25 divided by 9. These are the solutions for x. Now, what are the solutions for b? We have the square root of y is equal to b. So the square root of y is going to be 2 divided by 3. Again, we square both sides of the equation, and y is equal to 4 divided by 9. Also, square root of y is also equal to, the second solution for b is negative 1 divided by 2. When we square both sides again, y is equal to 1 divided by 4. And these are the solution for the problem. Well, it's an interesting one. See you in the next one.